As we're going through, if you have questions or anything, don't hesitate to raise your hand or shout out or whatever. It's totally informal. This is soil testing and interpretation. What do you need to know? If that's not what you signed up for, that's what this is. So now you signed up for it. I'm the Small Farms Extension Specialist and Soil Scientist at OSU. I am in the Department of Crop and Soils. I'm 7 months in. I just moved to Oregon from Washington in January. I started on February 1st. I was in Washington State for a long time, 18 years I think, and I worked in research there, agricultural research. So those two back there know all this information. Sorry. Cover crops, composting, lots of stuff. Basically, if you could get dirty, I was into it. That sounds terrible. Then I went and worked for a nonprofit for a couple of years, Silver Alliance, and then I moved here. And now I work statewide, so my appointment is statewide, if that means anything to you. I cover the entire state, which turns out it's a big state, and there's a lot of stuff. So I'm learning, but my background is in soil science, so a lot of this is going to be completely relevant. So first, before we even start on this, how many of you have had a class similar to this, either like in college or a workshop or a seminar? Raise your hand if you have. Sort of. Okay. So, because we're all new to this, if there's some word I use that you don't know, yell at me and we'll walk through it, because you have to gauge everybody's experience. So, if there's something I do not explain well, do not hesitate to yell at me, because we will figure it out. And we're going to partially talk about why we do it. And then, if it's not pouring rain, which now that I said that, probably will start again, we'll walk outside and sample some soils. So how many people have how many people have sampled their soil? Yep, and sent it into a lab too, I assume. No, just, okay.
Just looking at it.
Yeah.
It wasn't my soil.
Yeah. Okay, so why do we sample soil? This is a question anyone can answer who knows the answer. There's lots of good answers, but why do we sample soil?
It's not what we can grow.
Because all soil is different. You know what it is, you can make it what you want it to be.
Probably the
probably
most
not going to be what you want it to be.
fundamental thing is all soils are different. What other reasons?
Structure, fertility, microbial activity.
All correct.
Stuff you don't want to find out is there.
Excellent point. He said to find if there's stuff there you don't want, which is a terrible situation, but it does happen. So yeah, great point. Anybody else? Okay, so I don't break the computer. I'm hazardous. My own health. Soil is not homogeneous, so it's heterogeneous, which means it's variable. It's not the same. It can vary from, well, in fact, if you were going to be very, very scientific about it, it can vary from millimeter to millimeter, foot to foot, yard to yard. You all know this, I'm sure, if you've been working in a landscape or working on your farm. The soil is not the same. It depends on where you're at. So we are in that little pink square. We are here. Come on in. No, you're good. We're just talking about dirt. And some of this you have seen before. So we're here. This is Oregon. I've learned that. There are counties there. This is an overlay. We're going to go into a little bit more detail here, so don't freak out. But this is an overlay of the different types of soils in this area. So I just there's this big, huge data set that the government creates and provides us with this information for free, and I overlaid it on a map. And so we are here at the community college, and each one of these numbers is a different soil series. And you're going to ask me, what is a soil series? And we are going to get there, I promise. But each one of those is a different type of soil. So see that little highlighted yellow 79C? That in itself is a soil, some specific type of soil. And each one of these with the numbers around it and the squiggly lines is another type of soil. You'll see some of them are repeated in an area that makes perfect sense when you start thinking about soils. So each one of those is something different in some way, shape, or form. It's a unique soil. And that is the soil series. So what is the soil series? It is a taxonomic way to think about soil. So if I have a maple on the left-hand side and an oak, I can look at those and assess that they're different. Like a number of different ways, right? The leaves, the bark, the height, the width, whatever. We can come up with a bunch of different ways to think about it. Similar to soil, so we name those in that like taxonomy. So the scientific name for a red maple is Acer rubrum. So it sits within this family. Acer is the maple family. SacredThreeMushrooms, I'm terrible with that. I think it's silver, and then I don't remember what that was. But in any case, you get the idea. Maple family, oak family are actually the genus, and then the species. So white oak, red oak. Forgot that. But you get the idea. We do the same thing that you're somewhat familiar with, probably, with soils. We just taxonomically arrange them so that they have similar properties. And then we can name them, and that gives us a lot of information. So what is the soil series? Here are 4 examples of soil series. There are about 23,000 and some change soil series across the entire United States. You don't have to memorize them. Somebody asked last session if they had to memorize them. And I was like, no, I don't know that. I'm not sure that you can do that. But it's nice to be aware that some other, like as I described earlier, some other big nerds went out and like spent all their time thinking about soil. So you can see the differences, hopefully, in this slide. It's obvious. I'll use this as a pointer. What is the one thing that you can say that's different between those pictured on this slide?
Color.
Yes. Color. Color is one identifying quality or characteristic of the soil. What else?
Sediment size.
Yeah, absolutely. The size of the sediments, the different pieces. Anybody else?
Moisture.
Yes. Moisture could be one. Yeah, absolutely.
The consistency of the layers, you know, like whether or not it starts as homogeneous or it changes their deep layers.
Yeah, great. So notice that in this soil, Davidson, that's the state of Pennsylvania, apparently. I just learned that. That there are lines, let's call it. Separation in the soil. You can kind of see the color change as you move down. Less so in this one. This is pretty consistent. Also pretty consistent. And there is maybe some change in here. And then some change, not in the color. That's a little darker and then a little lighter, obviously. And then, but you get some change down here in the size of the particles of the soil. So color, alluviation, the separation of the soil, the size of the particles that are in the soil, those are some of the characteristics that we use to describe a different soil, the soil series. And it goes down kind of like the species of biology. So if we go back to that map that now is in yellow, we are in the blue dot there, and you'll see that, I don't know if I can use this cursor, you'll see the red X. And so I just randomly picked one of the soils. This right here, I'm sorry. I'm getting ahead of myself a little bit. This is a handout, and I'll just let you pass these around. That will have, that will have all of this information, so you don't have to worry about like taking a bunch of notes and writing all this down. I did that for you. It's there. This is a free resource that allows you to look at your soil series and identify what it is. It's on the internet, and it's awesome. So, if we zoom in to the location we're at Clackamas Community College, and we click on the soil, and I will do this live here in a second, but I want to show you this. This is Jory, which is the Oregon State soil. Jory is the soil series. And what you get is a sketch of the soil. Right-hand side numbers, 0, 15, 41, 48, that's all in centimeters. So it's telling you a depth. Each one of those boxes is a physical, chemical, or less biological, physical and chemical property of the soil that you can look at your location. As someone said in the previous session, this is really giving you a framework and giving you kind of like you're like creating this domain around what you know. It is not always 100% accurate. So it's just a piece of information to know. But if you have no information on the soil on where you're at, you can go and get a general idea. So what this does, so that 0 to 15, 15 to 41, 41 to 48, we talked about this earlier, about 6 minutes ago, about how the soil was separated by layer and depth. Those are telling you what the horizon is. You don't need to know about that, other than to see, like, oh, there's a change in the soil. They're saying that there's a change in the soil at 15 centimeters. So for your purposes or your planning purposes, it's good information to have. You don't need to go into all the detail of, like, what is a horizon? Now, if you want to, you can. But just to know that there is some change at 15 centimeters, which is like roughly 6 inches. It gives you organic matter, clay, sand, available water content, pH, got it. Well, probably way too much information than you really need to know, but it's a nice resource to have, like I said, to kind of give yourself a domain on where you're at. So if we go back. So this star, we're here in this section, and we just move over whatever that is, maybe it's 10 yards. Sorry if I'm not good at using a cursor. We're in a different soil. And you can see a clear separation by depth. So at 20 centimeters, you're going from that A peak to BT1. Again, not so much relevant to know what that is, other than that there's a change at like 20 centimeters. But you can see just by moving, whatever that is, 10 yards, that we're in a completely different soil series. So that information is free. That's like the first thing. If you are on a piece of land or you're on a field that you haven't done anything with, or this is your first time doing anything with soils, this is a great first resource to start with, just to kind of understand what's going on there. Yes?
I'm so sorry to interrupt.
No,
Do you
no.
have any more flyers? Because
if the flyers ran out, I also have I have an email and I will send it out. So you will definitely get that information. Don't worry about it.
Perfect.
Sorry, I was probably just bad printing on my part. Okay, I can't count. So better playing in the dirt. So let me back up though. So how many people who are farmers here? Oh, okay. And then who else is here? You can just tell us.
Just a home gardener.
Okay, great. Yeah. Home gardener.
Yeah.
Landowner? Okay. So let me, because it's a new topic for many of you, when we think about soils, we talk about them in, a number of different ways, but we kind of break them up into physical, chemical, and biological properties to understand them. So physical soil is what minerals are in it. What is the mineral constituency of the soil? The chemical properties would be something like pH. Does anybody want to play with dirt? I can ask. Sure. I have a whole thing. I mean, yeah, why not? It's fun. We got all kinds. It's free. So that's how we divide up soil to make it easier to think about. And that's also how we analyze it, generally speaking. There are ways to assess it, assess the physical properties, the chemical properties like the pH, or the biological properties like counting earthworms, which, if you have ever done that, it's terrible. Don't do that. The soil is going to be representative of the site's condition. I started off the last session with these 5 soil forming factors. Who was there that remembers it? I know you guys know.
what was that?
Who knows the 5 soil forming factors?
Paramaterial?
Paramaterial. What is paramaterial? Rocks. Yeah, basically.
It was biological, wasn't it?
Biological is one, yeah, organism.
Yeah, water. No, soil building.
so much information though. It's so much information. So climate, the soil is going to be representative of its climate, the organisms that are there, the position in the field that it's in, so if it's on the side of a mountain or in a valley, the amount of time that the soil has to develop. What did I say? No, I forget. Organism, belief, climate, and the parent material. So that, yeah. And the parent material is just the, oh yeah, you can, thank you. You can, yeah. The parent material is just the rocks in place.
And relief.
And relief, the position in the landscape.
Yeah.
But parent material, interestingly enough, can also be like a transported parent material. Has anyone heard of the Palouse in Washington? It's where a lot of wheat is grown. And it is a wind transported soil, so it blew across western, central, and then to eastern Washington, and then soils formed in that. So you can have all types of different parent material that the soil will form in, and it's representative of that area. So a soil in one place is, and I often say this, is not necessarily better or worse, because it's just representative of that area. And we're trying to understand what's going on in that soil, and we're coming at from the lens of like growing a plant, generally. Or if we're trying to find out why things aren't working. So that's another approach too. So how do we account for the variability on the soil? Well, we sample. And there's a number of different ways to sample a soil. And then we sample that soil and we send it to the lab and they give us some numbers. And we're going to talk about all that stuff. But sampling it's after you've done like 10,000 of them, it's not fun. But if you do 50, it's really fun. You can think about sampling in a number of different ways on how you would approach the actual thing, like actually going out and sampling. You can set up a grid. It's called systematic sampling, if you want to. Very little people do that because it's cumbersome. I mean, you're going to go out there and like mark things off. We do that in research for a number of different reasons. You can do that if you want. It's not wrong. It's not right. It's an approach. So you can just set up a very simple grid on what you want to sample, and that's one approach. You can do random sampling, which is way better because you just like let your mind wander and then you stick it in the ground. And then you walk a little bit more and you stick that sample in the ground and you pull it out. Making sure to get like a good distribution of the area. So it's like somewhat conscious random sampling. So that's probably the easiest way to do it. You can do stratified random sampling, and oftentimes this is what really happens, and I'll get to why. But this is just breaking an area up into units for whatever reason, and then randomly sampling in there. And then you're identifying that area for some specific reason that you want to understand what's going on in the soil. So, as an example, if you were on a property that had a lot of poop in one area, like a dairy, and this happens more often than you can imagine. There's a lot, because of the manure and how they manage cows, oftentimes they will field apply the waste, or the slurry, and the phosphorus levels are way off the chart, because there's a lot of phosphorus in RP and all that. You would set aside a place that you knew, or potentially knew, was managed in a way, or there was some unique feature or characteristic about it, because it's going to throw off all the other samples. What you do, which I don't know if many people really realize, when you take this sampler, you go out there and you get 15 to 20 cores to a certain depth. And we're going to talk about depth here in a second. But you take that, you mix it into a bucket, mix, send it to the lab. The sample that the lab uses in an analyzer, the analyzers are these huge machines. The sample is like this big, not a joke. So one of the important factors and things to think about when you're doing this is to make sure that you're getting good random samples and you're mixing it well in that bucket. And and it's amazing how accurate this stuff is. It's just this teeny little sample. So the point of this is that if you were to take one sample from where the poo guy is, it could potentially throw off the whole analysis, because one, sometimes you don't know. Like these can be key characteristics for figuring things out. But it's best, idea of what's been going on in your field, to kind of break these up when you're talking about sampling. So now, if you apply that same concept to the landscape scale, what you're looking at is thinking about management zones. Like, what am I managing this vegetable patch or apple orchard or whatever it is different than some other area? Is it different in the landscape? You know, whatever crop it is, it can make a difference on where that field is in the landscape. So you kind of want to group things together that make sense. So you've got some crop that's, I don't know, maybe you call it like a toe slope down there, or you've got a field that's up on the top of that plateau. And sorry, that's a terrible drawing. I did my best. But the idea is that we're thinking about not only the crop that we're growing, but the landscape itself, because the soil is going to vary based upon that. And so that map I put up earlier is a good starting place to start thinking about where we want to sample our soils. So sometimes you might get a change in soil that occurs like where you have your vegetables or your broccoli or whatever. And then you have to decide at that point how you're going to manage it, or maybe you end up moving the field. So it's good information to have from the government, the soil web app, and then start thinking about what you're going to do in the landscape. So these are general guidelines on how many samples you need. You are going to get, let me see if I can pull this up right now. Let's do this. So when you send in, sorry, we're going to see. Here we go. Okay, so this, sorry, let's go with that. This is why they don't run computers. These are general guidelines. What you're going to get from the testing lab is you're going to get there. They will tell you sorry, I'm having problems up here. What they're going to tell you is how much of a sample they need. So generally, it's often like 2 cups, basically, is what you're trying to get to, if you're looking at what a volume is. And they'll tell you very directly when you start looking at which lab you're going to use, they'll tell you what they want. And it varies based upon the tests that you're asking them to do. But they will give you that information very clearly somewhere. Okay, so these are just general guidelines. Usually it's like, somewhere between 20 and 30 is pretty good. But they'll tell you exactly. So when we go out there to sample, there are certain things that we can't change. Who knows what texture is? What is texture?
Texture is the aggregate. It's how thick it is, or thin it is, or
Close.
I wrote it down there.
I know.
Like what kind of components it has, so the proportion of sand, silt, and clay?
Yep. So there are 3 sizes of mineral. Well, there are more than 3 sizes. We break down soil into mineral size by sand, silt, and clay. And sand is the biggest, silt is the middle, and clay is the smallest. Clay is also a mineral, but we'll set that aside. So we're just thinking about the mineral structure of the soil. So whatever proportion of sand and silt to clay is called your texture. We can analyze that. We can assess what it is. In fact, there's all kinds of information on what your texture is, and you can look up how to hand texturize something. But is that something that you could change? I mean, you could add sand.
I was just saying you could add sand, right?
Yeah, you could add sand, yes. It would be very expensive.
Yeah, it adds up though.
Yeah, Fair point. Yes, it is something that you can change, but it would be very difficult and very costly and very expensive. And so that is a property that we're not really trying to manage. Sometimes we are. Very often we are not trying to manage that. These types of things they call static properties. Texture, that's something that's there. Sand, silt, clay, those sizes of those mineral particles aren't going to change. They change on geologic time scales. The depth to the bedrock also changing, but at very slow scales, and the type of clay that already exists there. So that's like the mineralogy of the clay. What type of clay is there? That's not going to change much. The dynamic properties, that's what we're trying to get at. We're trying to assess the properties that are changing in flux at either like, minutes to weeks to years to tens of years. We're in that dynamic property set. That's what we're trying to understand. So it comes to soil structure. That is what the soil looks like, essentially. You can look at the soil and describe it like this is an aggregate. It has sand, silt, and clay, and organic matter, and then they're bound together, and it's kind of round, for lack of a better way to describe it. But there are some soils that platy, I kid you not, is actually described as platy. It looks like a bunch of plates. That's how ingenious soil namers were. The point is, those are types of things that we can manage and we can assess. Bulk density is just the weight of the soil in a volume. Organic matter is something that we can manage, right? Organic matter is also, in a sense, equivalent to soil carbon, which is a big important topic. And then nutrient and water holding capacity. And a lot of the times, historically, we've been looking at this. Just the nutrients. Now, so those are the chemical tests, right? Phosphorus, calcium, magnesium, nitrogen. As we have evolved as people, we knew this a long time ago, it's just now it's more popular. We're looking at incorporating measures of water holding capacity, bulk density, and measures that assess the biological organisms into our assessments. So soil health, we talked about this earlier, that's what that is. But most of our information that we have now is based on this. And so recommendations from universities or whoever, nonprofits, are all based on this, the nutrient stuff. So that's what we, generally speaking, right now are working with. All the rest of the stuff we're developing right now. So soils are dynamic, they change. Your soil test is only a snapshot in time of what's going on right then. There are some of the metrics that we use to analyze soils that change between the sampling time and when you send it to the lab. And so we're just getting an idea of what's going on. A soil sample, it doesn't actually measure the nutrient, total nutrient. So when you're talking about nitrogen and phosphorus or potassium, we're actually measuring the nutrient that's expected to be available. If we measured what was really there, it's not as useful because we create these graphs and we correlate what is expected to be available with yield. And so we use a chemical extractant. When it goes to the lab, this is what actually happens. Yes?
Is this for acetate tests?
Pardon?
Acetate tests?
Yes, it depends on the nutrient, but yes. Yeah, those are generally. And I will get to those. Yes.
Is this like what's ionic or enzymatically available, or is this what's available to be exchanged by microbial interactions?
Good question. So it depends on the test. It is usually an extractant that we have correlated. So if I use some chemical, I take soil, I mix it around with some chemical, and then I literally stir it, agitate it, and then I look at the quantity of phosphorus, for example. And then I take that quantity of phosphorus, and at the same time that I have analyze the soil, I know how much yield there was, and then we make a graph. And so what we're doing is correlating the amount of the nutrient that we extracted with the chemical. I know this is so boring, but it's a good question. To the yield. And so we can measure enzyme levels, we can measure the microbial stuff, we can measure all those compounds, but they have not been correlated to yield. Does that make sense?
Yeah, totally.
So now, with soil health, that's what we're doing. We're doing the enzymes or respiration or something, and then looking at yield. But we have traditionally used the extractant method to figure out what we expect the plant to do.
Because what's there is not always what's available.
Correct. That is critical. So if I went in there and looked at potassium, K, everyone knows what potassium is, there are minerals in the soil that I could dissolve in a chemical extractant that would show up in the test, but they're not going to be available to the plant within the next 150 years. So we know that the chemical extractants we use are correlated to the yield. And so it's like, 100 years or so of soil testing to get these numbers. And I'll show you how that actually works. Does that sort of make sense? Okay, because it is the afternoon and everyone ate, and we're sort of tired. Let's stand up and we'll go outside. Because, yeah, that's what I'm saying. Stupid expensive. You can get the same thing for like $25 somewhere. So don't
Rent
look at
them too.
Yeah, exactly. You can exactly. And the conservation district, or if you have a local extension office, reach out to them. They will have them. You can use a shovel, and I'll talk about that in a second. But I'll tell you why this is well, it's more time consuming, but it's better in general. So again, conservation district, ask them if they have a soil probe, a soil sampler. This one has this handy dandy little thing that pops out the core. I used a screwdriver. So that's, I don't know why you would buy these, but I didn't buy them. I borrowed. So when we go out to sample your soil, have an idea of what you're going to do so that if you choose to do the grid sampling, have it all laid out. If you're going to be random, be clear of mind that day. I don't know. Know what your management zone is, though, so that when you get out there, you can switch. So what I do, and I exactly do this, I just have a bucket, and if we're doing like research, I'll have multiple buckets because I don't want to contaminate the soils. You can have that, but you can also just have a bucket with bags. So depending on what lab you go to, they'll either provide you a bag, that's less the case anymore, or just use a Ziploc bag. They will also tell you if you're doing a microbial sample that you need to keep it chilled or put in the refrigerator is fine. Or if you're going to be out there all day, have a cooler. That's what we use. But this is all day sampling. I can't imagine you would want to do that. I hope you don't do that. It's terrible. But have it marked. So you're in, let's say you're vegetable garden 1, and you have vegetable garden 1 through 3. You've got a Ziploc bag, and you know that that's vegetable garden 1, and you're going to pull your samples from there. And so have that all laid out. If, like I said, you're going to send it to the lab for microbial analysis, make sure that you're able to keep it somewhat cool. And then, you can send it that day or the next day or whatever. Or you can drop it off if you're lucky and it's like right down the street. Okay. What depth?
What are you planting? For 6 inches.
Exactly. That's perfect.
Roots going.
Exactly. Basically where the root zone is. There are cases in like Eastern Oregon where the recommendation is going down to a foot, and there are reasons for that. It's because they get less rain and there's nitrates, and that all has been correlated over there. Where we're at, it's generally best just to go to usually the recommendation is somewhere between 6 and 8 inches. It depends on the crop. But go to where the roots are. So, an orchard, that is a great question. I do not know because I do not do orchards. But they will have a recommendation for the depth. Somebody who does orchards will know. That might be like a foot. That's a guess. Yes.
So I just did the dry farming accelerator.
Yes. Yes. So
annual plants usually is what we're looking at in vegetable gardens, and we just go down to 6 inches because that's also what the recommendations come from, is the 6-inch depth. So if you're doing dry farming, that is different, and that will have its own set of guidelines for that. But yeah.
This is probably applicable.
Yes.
Going deeper and looking at nutrients way down the subsoil.
Correct, right. And you can always go deeper to look at those subsoil and nutrients, to your point, if you're interested in. What the most important thing, and like probably ad nauseum because I say this all the time, is the same time of year, be sampling at the same time of year. And whatever depth you choose, keep it consistent. Or you're not going to be able to compare from year to year or season to season. And you can decide for your own, because it's a cost, oftentimes you can usually find a conservation district that will provide a certain number of soil samples. I think they pay for some of them. But then it's going to be on you to pay for it, and so you can figure out how to adjust. Oftentimes the recommendation is, every 3 years, depending on who you ask. If you are in you could go every season if you really wanted to see the change with what you're doing management-wise, but usually the recommendation is somewhere every 3 years.
I would also say that labs are pretty backed up and jammed up, so you might want to plan ahead.
Another good consideration, if you are thinking about, let's say you're in the spring and you're going to sample in the spring and you're going to use that sample to then plan your nutrient management, take into account that what lab you're sending it to. Also, and we'll talk about this when we go back in, use the same lab. We'll talk about why that is, because they use different analytes that will get to the same nutrient quantity, but it's a different path. And if you use a different path, you cannot compare the two. There are some cases where you would have to do some math, but you don't want to do that. So the easiest thing is to use the same lab at the same depth, same season. And then make sure you write it down.
Certain season recommended?
Generally, the simplest recommendation is in the spring, prior to planting. You can do other sampling. There's no problem with doing, you can sample whenever you want, but you could sample in the spring, you could sample in the summer. Some people do mid-season nitrate. Some people do a post sampling in the fall. So after they've harvested, they'll look to see what's left in the soil as a way to think about it. And there's in that sheet that if you didn't get it, I'll email it to you. There's recommendations there too to help you decide what to do. But the simplest, fairest is do it in the spring.
And before applying any...
Right, exactly. Yes. Before you've done anything. Yeah. Excellent point.
And I think also that post process of an analysis for organic farmers, it takes time to build up your nutrients and your cycling.
Right.
So knowing then what you need to do to kind of build that soil up for the next season over the...
Yes. Yeah, and there's some considerations with nitrogen there too that we're going to talk about inside. So that will be specific to the nutrient. I'm trying to think if there's anything else that's really critical. So you're in your management zone. You know the depth that you're going to go to. Maybe if you're dry farming, you're going really deep, or you have your bag set up. And very simply, what I do is I mark off on here like with a piece of tape. I just use duct tape at the top, not duct tape, masking tape at the top of the depth I'm going to, and I just stick it there because I'm terrible at estimating that. So I just mark it on there. If I would go to 6 inches, it'd be something like there. And then you just take the sample. And it's going to be, this is probably a full foot. It was great if you're in the spring, hard. And the soil is like field capacity because it's just easier to get it in. I mean, that's yeah, exactly. So there's a reason not to do it when it's dry. But you can sample that way, it's just harder. So you'll get a sample, and like I said, if this had gone to 6 inches because it's not totally dry, then you just pull this out. This has this nifty, which I don't even think works that well. So don't spend the money on this. And I just have a screwdriver, I pop it out, I stick it in. I'm gonna do 15 to 20, let's say I've got an acre vegetable or something. So I'm gonna go around, and you're being random, but you're also conscious of making sure you're covering everything, right? So going to the corner here, or whatever it might be. In the bucket it goes. At the end of it, take your hand in there, don't use a metal bucket, plastic bucket. Metal bucket, aluminum can influence the test. So the plastic bucket, stick your hand in there, break it up, mix it up. Like that kind of came out in, kind of as a core pulls it out. So I just break that up well, big bunch of mixing, and then it goes into the bag. 2 cups or whatever they ask for, 2.5 cups. Sometimes they ask for 4 depending on the test.
I've read that you're supposed to discard like the top of it.
Yes,
Especially
so
for
in
veggie farmers,
this,
because like we use a lot of mulch and things.
right, depending on what system you're in. So if you're in like a pasture or forage, you pop off the grass piece and the thatch. If you're in a vegetable where you're tilling a lot, you don't have to necessarily worry about that. The lab will remove a lot of the organic matter as a part of their process. If you use a lot of mulch, scrape back the mulch when you're sampling and then go to the soil. Try to get as much just soil as you can, but the lab will remove that like extra organic matter.
So like on my farm we use like compost mulch and straw mulch and things, and so like when I scrape that off and then I take the sample, like the top 4 inches is like dark as hell.
Right.
And then after that, it's clearly just straight up clay.
Yeah.
At that point.
Yeah, yeah.
So like, am I testing for the clay or am I testing that top?
So that's a good
that
question.
I've made?
So it depends on your management strategy. In your case, what actually happens, are you a no-till system? So what they recommend in a no-till system is actually doing incremental, like 2 inches, 4 inches, 6 inches, because in no-till systems you can get basically the nutrients aren't moving in the profile, and so what you're trying to do is make sure that you're not hitting some concentration that is going to be toxic to the plant. So in a no-till situation, it's a little bit different sampling regime. You would still remove the organic matter and try to get down to the soil itself. But it's
you would do separate, like
correct.
A separate test for the top.
Yes, exactly. Yeah, and it, I can look this up, but there is a specific recommendation for that, and I think it's every 2. Don't quote me on that. We can
Yeah, the lab I used didn't talk about that really. They just said to scrape that top, like the whole thing right off the top.
Yes.
Yeah.
And so what you'll learn if you're dealing with a lab is they're a business. They don't care. And very literally, if you've ever been to I don't know why you would go there, but it's a bunch of machines that are processing like hundreds of samples in many cases. And so you're a number. So find a lab that the person seems responsive, but there is a publication that I will tell you about that has different questions you should ask the lab prior to sending the sample. So you want to talk to the lab about your system if you can and find out what recommendations they might have. OSU, the piece of paper that I have, has a huge, there's 3 or 4, I think, publications that go through what you should ask the lab. And so that will help you. Yeah.
I was able to test and send in a crop that I'm growing and they gave recommendations based on that.
Yes, exactly. And the other thing, thank you, that's a great point. So whatever crop you're growing, they will use that information that I spoke about earlier to the yield, and that's what their actual recommendation for your application rate will be based upon. And that, and they'll ask you too, what crop is it? Sometimes they don't have that information though. The lab, if you're in a, I don't know, if you're in a niche growing area, or maybe if you're doing like dry farming or something where the recommendations just aren't there, they're just going to provide you a number, and then they'll show you where those values sit against everyone else, but it's not going to be a specific recommendation.
I grew taro, and so they didn't have a specific one for taro. It's kind of
Yeah.
They were like, you're growing something that has a form,
Right.
kind of, so they gave recommendations.
Right. Yeah. Makes sense. It's close. It's not the exact thing, but it should be similar. And what you can do then too, depending on how much time you want to invest in it, is figure out what that difference is like, oh, this is actually what I need versus what they're recommending, and you can maybe you drop it 10% or you need 10% more. You know, as those crops become more popular, then you can figure out, and you can actually fine tune it yourself. So
We'll
it's
call you when we need to know our
yeah. We could set up a research project. So that is, I mean, it's pretty straightforward. I'm trying to think of anything that comes to mind that is really difficult that you run into. Rocks I mean, you run into rocks, just sample around it. It's not that big of a deal. Roots, be careful. Sometimes you run into an area that you just had no idea there was a tree there or was long gone, and you'll get a big root stuck in there. Look at the sample and make sure there isn't like a big chunk of root. That'll throw off the whole organic matter big time. I think that's pretty much it. The lab thing can be very irritating when working. They're commercial, so they're selling a product, and sometimes they don't spend a lot of time. So you have to be very diligent.
And there's no locals?
That is a good. Actually, I do not think.
A&L.
A&L, I think. Yeah.
Yeah, I think they might be the only one. I think there's like only one.
Yeah, they've run out of concentrates.
Yeah. And so we'll go in here in a couple minutes, and we'll talk about the analysis that you want to make sure you're asking for in Oregon.
Based on where you are, right?
Based on exactly. And I worked with a farmer out in Cove who had sent her samples to a Midwestern lab, and they used what they would use in the Midwest, which is not what we use here, and it's not related to anything we have. And so, what? Yeah.
I was like in Cove?
Yeah.
It's like
Good point. I should know. Yeah. But we figured it out though, so that is good. So it's like the actual process of it. It's pretty straightforward. It's just making sure that you're communicating with the lab if you can, and know what you want from them, and you have to tell them. So that's the most important part, I think. And we'll go inside now, and we'll talk about that, and we'll look at like the actual interpretation of the text. Oh, if anyone wants to try this, there's, feel free.
You found a good spot.
There are other, what I should recommend is there are not these expensive ones with this stupid orange handle. They're just one piece of metal, and they have a
kickstand.
Yeah, they have a foot thing. It's way easier. So if you're gonna go purchase one and you can get the $20 one, get the one with the foot so you can just press it in. It's real easy. And the diameter, it doesn't matter. They often have different diameters. It doesn't matter. You're using the same soil sampler. It's fine. It doesn't matter.
I participated in this study that some cool farming group was doing, research group was doing, and they came out to my farm and did like bug analysis and water infiltration tests and like this whole, took them a day, and they had the soil probe that I'd never seen before. It was like this tall, straight from the ground. It was like, he was hitting it with a sledgehammer. It would go all the way. I mean, it was going like feet down. So I can't wait for the analysis for that. Yeah, that'll be cool. They are hammer probes. So there is, and this is when your life is taking a bad turn. When you're standing out in the middle of a field in the middle of nowhere, and you have to like hammer probe because it's heavy, it's weighted, and you're going down like 2 feet. That's when you question your life. Like, why did I get into this? He was getting after it.
Yeah. So
and you said we could do it with a shovel, though.
Yes, you can definitely do it with a shovel, and I should have brought the shovel. But basically, what you do is take like a spade and go into the ground to the depth that you're sampling to. Kind of, put the shovel in the soil. Do this. Come back behind that, and you can do this a number of different ways. And then you're basically making like a small cut, like you would the width of that spade, or even like half, because that piece comes out like this. You can break it, remove the material from the top, and then break that piece off, and then throw it into your bucket. The problem with that, it's not a problem. It's just that if you want to get variability and you want to, it takes longer, because then you're like taking a bigger piece and you're cutting it off, and you got to do it more, and it's more work. This is just not this $400 one. The $25 one is a much better investment, and it's way easier.
I can't believe that's $400 and they don't even have a foot.
Yeah. I think it's I don't know. That's why I was like, is this fun?
$450 if you want the foot pack.
Yeah.
And leather looks exactly like that.
Yeah.
I think I paid like $70 for one like that.
Yeah, exactly. Yeah. Oh, okay. So, is everybody if you want to try? There's this tall. Oh, and there's different heights, obviously. So depending on whatever, you can get ones that are up here, and the foot pedal is really the nicest one. It just makes it easy. And they're, like I said, there are ones with weighted. You don't need that. Don't do that. And the diameter doesn't matter, because it'll be consistent. Whatever you do on your farm, it'll be consistent.
Why would you get a shorter one versus a taller one?
It's $400 instead of $450.
Oh! Yeah, that's true. And the other thing that I was given this similar talk somewhere, and somebody reminded me that these are great for evaluating soil moisture. If you have this out in your farm and you just shove it in whatever you're farming, you can pull up to a foot and really see, like, you can feel it. It's the simplest tool for soil moisture. If you don't want to buy a sensor or you don't feel like dealing with the sensors, then you're going to download it. This is awesome. And you can really tell, like, how deep, and you can see it and you can feel it, and it's really good for monitoring the moisture in your soil. So.
Soil biopsy.
Yeah, it is. Yeah, yeah, exactly. So you can just learn so much just by digging in the ground. Okay, we'll go back inside and talk about soil test interpretation.
That's a great question. I've never really thought of human evolution. Yeah. So in general, these are kind of the 9 things that we think about when we talk about soil, the benefits that we receive from it. And you'll notice that some of them, let me back up. We look at it, these are things that just happen. Some of this is anthropomorphic, meaning it's coming from our perspective, like we gain from these processes that we're going to talk about here in a little bit. Then it's just the outcome of that, like climate regulation and water infiltration. That just occurs naturally. We don't have to do much with it. We can protect it, though. But it's not, it's always I think it's a juxtaposition soil. It seems so simple. You walk around it, you grow plants in it, you have a garden, build your house on it, or a barn. But really when you start to think about it deeply, you're in this space, and the reason I put this picture up here is the lithosphere, which is like the mineral part of the earth, the atmosphere, the biosphere, and the hydrosphere. And all of those things are interacting at that interface. And so you have all these interactions, minerals, water, air, and talk about this here in one slide, and all the chemical processes that occur are happening in that 1 to 2 meters, really. Some maybe it's 3 or 4 meters in some areas, but you can go out there and look at the topsoil, and it's all of those interactions are occurring right there. So it can be very complicated because you're trying to think about and model all these different interactions, and then assess what comes out of it, and then try to manage it in a way where you're not destroying it. So it can be very complicated. So has anyone ever seen a slide like this before? So if you took, if we went outside, and actually we have soil here, I can pass it around. If you take a little bit of soil, you all have seen this, you all work on farms, or some type of land management. Any volume of soil that we have in our hand or a shovel or whatever, half of it is mineral space, roughly. These are kind of idealized, like it changes from place to place, but basically 40 to 49% of it are mineral. It's just rock. 25% of it is air, 25% is water. Obviously, those fluctuate when you have precipitation and those types of things. And then somewhere in the 1 to 10% is organic. That varies by region and by climate. And then,
does it also vary just space to space?
Absolutely. Yes, it does. And then you have a very, 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 very small portion of it is actually alive in the active microorganisms, but they have a really big outside impact. So yes, when we talk about soil, there are 5 soil-forming factors. So climate is going to make a big difference. The organism that's there, which is related to climate. The parent material, which is the rock, here's the dirt there. So if I went parent material, if we went to a prairie in Kansas, it's going to be some type of soil. If you go to a soil closer to Mount Bachelor, there's going to be some influence from the volcanic ash. So that's part of the parent material that's going to be inherent in the area. Yep. Organism, parent climate, time. So over time, things change. They evolve. The physical processes, erosion, weathering, that makes that soil in that place. And then relief, which is the position of the soil in the landscape. So on a mountainside, there's going to be very little soil, if any at all. And as you move down that mountainside, obviously the soil gets deeper and deeper towards the back. Does that make sense? Okay, cool. So it's variable, right? There are a lot of different things that can occur at a site. You can have changes in air, you can have changes in water, just as we discussed about the parent material. That mineral can change. What you want to think about, I think that I often, when I give these talks, I always remind myself and everyone that half of this, if you really think about it, that top half is what? Yeah, but what's another way to think about it? That's correct, but it's just space. So half of the volume of the soil is, in a sense, open space. And when we start thinking about soil health, that is one critical thing to keep in your head about open space in the soil, because there are organisms in there like us who have to breathe, and they have to eat, and they have to have some water. So half of that in a known volume is space. And one of the simpler ways to think about soil health and how you manage it and then assess it on your farm is that you're really trying to create an environment for the organisms to do their thing. Whether it's cover crops, microorganisms, fungi, whatever it is. That's what you're essentially doing. The easiest way to think about it, minus all the metrics that we can think about. So from those properties, because soil is complicated, we like to divide things up, or people that think about it and want to do stuff like this, because it's easier to understand. Sometimes they say in life, like you're either if you're a scientist or whatever you do, you're either a lumper or a splitter. Like you want to bring things together to understand it, to group them, and kind of understand what that is, or you split things apart to have a better understanding. So in soil, it's, in this case, oftentimes you'll see things broken apart biologically, chemically, and physically. And that's how we assess different things. And then the intersection of all those is what soil health is. So you'll see, depending on if you use a lab or you use like a commercial lab, you'll see different types of numbers to help assess soil health if you send it off to a lab, a commercial lab. And those are combining different components of physical, chemical, and biological properties to arrive at a number. Yes?
Does the Department of Ag or anyone like that provide soil testing for folks if they need it?
Okay, that's a great question, and this is going to vary by county. There are, I think, conservation, so let me back up. In Washington, there are conservation districts that would help provide and pay for, like your first soil sample or your second soil sample. I believe that would be the same here. So the conservation district would be the one to reach out to and ask if they have a program. I don't know off the top of my head if the Department of Ag has something, but it'd be worth looking into.
I know Tualatin Soil and Water Conservation District offers a free soil test. It's the basic one, so it doesn't do micronutrients, but yeah, that's a great place to start.
Thank you, appreciate that.
Thank you. Yeah, that's great.
What was it?
The conservation district. Yeah. And you can always reach out to OSU Extension too, and they can point you in the right direction. There's a lot of people out there that are more than willing to help. So to that, like we use those tests to assess all these properties and then think about what that does in that environment, and then we call it soil health. And there is a lot of interest and effort going into soil health, but I think it's also important not to get too caught up in the numbers themselves. And we're going to kind of talk about this as we go through these hands-on exercises. A way to think about it is to think about soil as a resource. And whatever the number they say as far as soil health, what we're really trying to... sorry, I thought I saw a deer. It's a dog. Sidetracked like a squirrel. What we're really trying to do when we're thinking about soil health or managing our soil is protecting that resource. We don't want to lose that vital resource through erosion or whatever it might be, to contamination. That's what we're doing. We're doing our best. We're doing the things we can, management-wise, to protect that resource. So here's a list, it's not even a full list, of measurements that we might do to evaluate those different properties. So physical, has everyone heard of aggregate stability? Rick, if you have, yes. If you haven't, that's okay, we're going to talk about it. Infiltration, is just the rate at which the water goes in to the soil, right? That's pretty simple. Water holding capacity is the amount of the volume of water that the soil can hold. The bulk density is the weight of the soil, like in a volume. So if I filled this up with soil, this is a known volume, I can figure out the volume of this, and then I weigh it, and then I run that calculation, which is just a ratio, I get a number. And so if there's more soil in this volume, the bulk density is going to go up because the weight is more. So if there's less soil in there, then the bulk density number is going to go down. Remember in the beginning, just a few minutes ago, I said what is half of the soil? It's space. And so bulk density, soil bulk density measurement is a way to get at that space. So if I took a soil in here, it's at its whatever, its own bulk density, and I just went in there and just compacted it, I can add more soil, the weight's going to go up. So that's a way to get at understanding that there's space in your soil.
Which is good.
Yes. So just think about like the space in a room or like a microorganism living there. You want some room in there.
You want soil. Well, I guess this might be a really stupid question, but
Nope.
soil versus dirt, which I'm sure is pretty much the same. But like, when I think of soil or like dirt, it's like moist, it's compact, it's dark.
Yeah.
You know,
Yeah, there's a color to it.
yeah.
Something like this.
The dirt that I have, that I'm trying to garden out of, at my like fourplex, is very light, very like it's like dirt. I don't.
Yeah.
Like
So we're going to end that. So yeah, that's a good point. So it does vary, and there are limitations by those things that we talked about, the parent material and climate. That stuff has a limitation on how I'm going to say how healthy or what.
What's the variation?
Yes, exactly. That's going to influence the potential of that soil. There are limitations based upon some of the things we're going to talk about. So, but great question. So the chemical stuff, I know you've all seen this soil organic matter. How many have gotten a soil test sent off? Okay. So when you get a soil test, if you send it off, you get information like nutrient concentrations, like potassium or phosphorus, something you might apply, nitrogen in some cases, carbon, magnesium, calcium. pH is something else we monitor in the soil. Salinity, not so much on this side of the state because of all the rain you get, but in some areas we can monitor that for lots of fertility, or if you were adding way too much fertilizer. But in general, so those are kind of just illustrations of some of the chemical properties. And then the biological stuff, microbial biomass, earthworms, respiration. So this is identifying what's there and who's there and how many. We can measure that. You can use molecular methods to do that. This is just a count in many ways, just to see what activity is going on as a result of the number of earthworms. And then this kind of gets at both of those without actually measuring them. Because these things have to breathe, and we can measure this to see if there are organisms there, and we can measure their respiration. So to your point earlier about space and different types of soil, space gives these things a place to live. And so we can measure that. We can measure the respiration off of the soil.
Okay. I just like wondering, because like, you know, the soil at our farm is like, you just tell it's healthy soil.
Yeah.
The soil that I have and where I'm like going to grow garden is like, there's no worms, there's no bugs.
Right.
It's just like, you can tell it's like very unhealthy soil.
Right.
But
Yep, and that's what we're trying to get to the place where that soil can be its healthiest. It may be different because of the area. Like a healthy soil on the west side of the state is going to be different than a healthy soil on the east side of the state, right? Just from precipitation alone. We have way more biomass over here than, I don't know, pick a lot of different places. So it's just going to be a little bit different. And those metrics and the values might be different. Healthy soil on the west is not going to look like a healthy soil on the east. Yes?
Well, is there any consideration for like the Missoula floods? Like I'm in Columbia County and I'm literally slammed where they stop.
Yes.
So I have
Yes.
all of these different types of soils. I have 3 states worth of soils.
Yes. Yes, we are going to get to that. Yes, there are like there are ways to think about that and ways to still manage that. So this is the definition of soil health the USDA, if you're familiar with the Department of Ag, is now promoting. It's defined as the capacity, continued capacity of the soil to function as a living ecosystem that sustains plants, animals, and humans. So ecosystem, we're considering and concerned about the system itself, the living parts of that, and maintaining it. So we're protecting that resource. The other way I like to think about it is that we're avoiding degradation. This is what we're trying to avoid. There are ways where you can do certain practices that may or may not improve your soil health, but you may not see like an increase depending on what number, if you're using some a value. But what you're also doing when you're thinking about managing soil, you're avoiding all of this.
That's basically what I'm saying.
Right. So that's the other way to think about it. Don't get too caught up in these numbers, but you're looking to avoid the degradation of the soil as well, not just looking at the values. So we're protecting soils to avoid degradation. And we want our soils to look something like this. On a spectrum, because certain soils are in ways because of the environment, or because of the texture of the soil, which we're going to talk about here in a second, or because they were at the end of the Missoula flood. So there are just certain limitations of your soil that are inherent. They're just the properties of, the randomness of weathering and erosion and the different physical effects. So who knows about texture? Did you know? Okay. Who hasn't heard this term before? Has everyone heard this term? Okay. So sand, silt, and clay, right? The three sizes, we can measure all these in the soil. We are now looking at the physical properties, the physical stuff. We're actually looking at the size of the mineral. These are the different sizes, and they're relative to each other. So sand is the biggest, silt is somewhere in the middle there, and clay is really small. You can measure the proportion of sand, silt, and clay to each other. So if I said like there's 70% sand, 10% silt, and whatever I can't do math, 20% clay, we could figure out the type of soil that is, and we would have a name for the texture. Some textures are sandy, some are sandy loams, some are clay loams, some are clays, some are silt loams. There's an entire other group of even bigger nerds than me who have figured this out, and they will provide you this information. Actually, it's free, and I will show you this in a little bit.
That looks cool.
We can figure out what the texture of the soil is. And I said there were percentages, so you see the different percentages. So if you have 70% sand, it's hard to see on this slide probably, and there's a little white line that you follow, and then you have 30% silt, somewhere in here, and then you have 10% clay. We're like a loamy sand. And this is the soil texture triangle. So we can assess the minerals in our soil and their size, and that gives us the physical property of the texture. Sand, silt, or clay. What does that tell you?
What you can grow. How deep you need to go and what you can grow.
Say that again.
How deep you need to go and what you can
How
grow.
deep you need to go in the soil. What else? Anyone else? Go ahead.
Water retention and drainage.
Absolutely. Anyone else?
Certain amount of spaces.
That's related to that? Yeah, absolutely. She said spaces. He said water retention and water infiltration. Yes, sir.
I would say surface area for microbial activity.
Absolutely.
pH to a degree.
pH to a degree. Yes, it could. Yeah.
Clay content is going to be higher.
Yeah, it could affect pH, right. What about nutrients?
Yeah. Oh yeah.
Yes. So all of that information on how your soil is going to perform is kind of predictive in a way. If you know the texture of the soil, you can say sandy soil is going to drain quicker and it's not going to retain as much nutrients. So you may have to apply more frequently. You may have to think about how you're watering in your irrigation regime if you're in an irrigated area. If you're not in an irrigated area and you're dependent upon natural rainfall, you've got to think about ways to keep that water in the soil. So just knowing the texture gives us all its predictive properties. And think about here, if you have a sandy soil somewhere in western Oregon or western Washington, and that soil doesn't retain as much water as, say, a clay soil is going to hold more water because those particles are smaller, and they're going to create those little spaces, micropores in the soil. It's going to retain water, like in the spring, for example. And water absorbs what? If the sun is out, what does water absorb? Heat. So it's going to take longer for a clay soil to warm up. So you now have all this information just from knowing the texture of your soil. And it gives you this ability to kind of plan and contemplate what you can do. What this also tells you is some limitations. So a sandy soil is just not going to hold as much moisture as a clay soil. And so when I talk about like soil health values, if you go deeper into soil health and you start sending this off to different labs and you want a number, there's just going to be limitations on a sandy soil. Will only be this number. It'll never be more than, like, it's difficult to, you would not want to compare a sandy soil with a clay soil and say one is healthier than the other. They're just different. Within your system, though, within a bunch of sandy soils, you can kind of get metrics that will let you know what you're doing is changing some component of the soil. Does that make sense? Mm-hmm. Awesome. Okay, so there's so much information on soil health and how to, one, implement practices that try to get to improving soil health, and there's information on how to assess it. So this comes from the NRCS, which is the Natural Resources Conservation Service, and is anyone familiar with them? Sure. Yeah, okay, great. They can provide you not only, you can work with them for funding if you're on your farm, you can work with them for help on soil health. It's a great resource in your area, and they have service centers all over the state. I encourage you to reach out to them and get to know them. But they have created a lot of information. This is in that packet that I gave you. So anything that I'm talking about, there is a link to that information. So if you're already bored of me talking, or you want to learn yourself, depending on how you learn. But that all to say, there are kind of like 4 things we think about as far as management-wise. You want to maximize the soil cover. Why would you want to maximize the soil cover?
To prevent erosion.
Exactly. What else?
Retain water.
Yep.
Nutrients.
Yep.
Regulate temperature.
Yeah, exactly. Awesome.
You don't want bare soil, right?
Right. Bare soil, bad. If that's the only thing you learn from this, then we have succeeded. Bare soil, bad. Okay, so with that, related to maximize soil cover, maximize living roots. So if we can keep roots in the soil, they're going to create channels. They're going to promote aggregation, which we're going to talk about. Space, exactly. They're going to provide nutrients to microorganisms, and plants are good, right? This is not, and I'm a soil person. Minimize disturbance. You've probably read, if you've been paying attention to any of this stuff about no-till or reduced till or strip till. If you can reduce tillage on your system, that's great. A+. You're going to reduce erosion. There's all kinds of other factors that you will help yourself. And then maximize biodiversity. It can be all of these can be very complicated depending on where you're at. But this can be pretty complicated. This generally is, I think of it as like, you can maximize biodiversity in the soil if you're adding like compost or you're growing different plants. Like you're kind of maximizing biodiversity in a sense. But when they talk about this, they're usually talking about animal integration, chickens, pigs, incorporating that into your system in some way. Or what you could also consider maximizing biodiversity is integrating like perennials into whatever you're doing.
That was my question. Are there planting strategies that you can do on barren land to kind of bring it back to?
Yes, absolutely. There are entire videos and entire courses on that. So yes, there definitely are, depending on your situation. The other thing to think about, when I'm standing up here, it's much easier for me to tell you these things. It's different when you're on your place trying to figure it out. This is idealized. Maybe you can't do it. In some areas of Eastern Oregon,
like if you wanted to incorporate cover crops where it's unirrigated, they don't have enough rainfall. And so they're not going to incorporate a cover crop, or it's going to be difficult and you're going to really have to plant it. It's not that you, again, it's not that you can't do it. These are all the things in a perfect world, in this great environment, if you have the loam soil, and you have all the money in the world, and you have all the help to do all this, this is the idealized thing. But if you think about each one of these as something you're going to try to tackle a year, 2 years, even if you pick one and get really good at it, that's a great step. These are just all the things that people think about when they're talking about soil health.
Is there a point in which, like, it's recommended to till or to, like, replace the soil that's currently there with, like, fresh, new, like, soil?
I think, so that's two things. If you replaced it, it's going to be really expensive. And so
if it's like this big strip right
you
here,
could do that, sure. In cases, and there could be lots of different scenarios, but if you have a really compacted soil, sometimes you have to take the deep river through there to get started. And then you can maybe put in some, I don't know, I had a friend that did a research project with the radish, daikon. So to reduce compaction, it was terrible. They ripped it with a deep ripper, and then they planted radish in it and let it go for like 2 seasons. And so the radish root goes deep, it's thick, it breaks things up, you add a bunch of organic matter. So there are, like, I think that's what sometimes it doesn't get communicated. Like, if you have to till, you have to till. You have to, it's your livelihood. You know, these are just concepts that are there for you to think about and like, oh, can I try this? Can I try cover cropping? Can I, so I had a friend that worked on reduced till. So, you know, they have these machines that instead of tilling the whole thing, you know, like if you have a BCS or something, we were walking behind it, they have ones that are just like where you would plant. So they're small, you know, tillers like this size. And so you go from tilling a whole bed to whatever your BCS or your tractor from this to this. So that's an improvement. It's not no till, but it's an improvement. And you're making a step in the right direction. Even if, like I would say, because I am a big fan of cover crops. Also, look up the Western Cover Crop Council. I may or may not be a part of it. But it's a nonprofit. So if you can figure out a way to like incorporate cover crops into your system, you're going to do this. You're going to maximize soil cover. You're going to do this, and you're going to do that. That's great. If that's the only thing you do. I mean, you have to figure out what works for your system. So I'm just giving you these ideas. They're not even my ideas. I'm just regurgitating. But don't feel, I guess the thing about, when I talk about this is I don't feel constrained by it. You know, you're just trying to work things in. Okay, so there are so many other things we could talk about, and there's a whole metric system of soil health things that are becoming more popular in commercial labs. But I think it's more useful. And maybe, I don't know if it's more interesting, but I think it's more interesting. But it's more useful for you all to kind of have a way to evaluate that. So let's go outside, and I'm going to show you things. And I'm going to tell you that we're going to go, I took all this information, and now we're going to like figure out ways to measure it. So physical, chemical, biological properties, the result of that is some type of soil something. And we're going to try to measure those so that we're getting an assessment of those, but it's the intersection of that. Points on it. Small and a large, so that's the small one, and you can see the other one is just attached to it. It comes with those. The smaller one is for compacted soils. Hopefully I didn't do this backwards. I always have to look it up. The smaller one I'm pretty sure is for compacted soils. So, yeah, that's right. If you have like what you think is a compacted soil, then
more clay.
Yeah, generally. You want to use the smaller point. So you can see the notches on there. I think they're 3 inches. So each one of those notches is 3 inches. Oh, now it's good. So you can tell what your depth is at, and it's really simple. You just, and I'm going to do it on this path because it's going to be compacted. But so it's really easy. You just lean on it. Okay, so on that, and everyone should try this. inside circle it says small tip, and then outside circle it says large tip. So 300 is where you hit some type of compaction.
Okay.
So you're assessing, you're pushing down, this thing is pushing up, it's measuring the resistance as it goes through the depth of the soil. It's real simple. But 300 on this, on the small tip, it's marked, it's red. That's a zone of compaction. So you can push down on this, and not surprisingly, we got about, what is that even? Centimeters in? And we're at that level of compaction, which makes sense because it is a compacted walkway, so it works. Now, you can go, obviously you would do this in your field, and this is going to be a little bit different because this is probably, there's like 70 inches of something. Okay, so in case of, I'm going to do this. That'd be terrible if I lost that. I borrowed this from somebody, so I get in trouble. Okay, so same thing. I very literally just push it into the ground. Oops, if I would read the right way. So now, yeah, there's still some compaction there. Not that deep.
How much of your weight are you putting on that?
So I will let you try it. So you'll feel like you can tell. It's hard to describe. I'm trying to think. Yeah, just kind of you know how they say finger tight when you screw something.
Mm-hmm.
So this is just kind of pressing into the soil.
Okay.
The other thing that I should have mentioned first is critical, is that you need to do this at a time when the soil is at field capacity.
Okay.
Does anyone know what field
Not
capacity?
mud, not muddy, and not dry.
So field capacity is basically the moisture in the soil after like a good soaking, about 24 hours, when gravity has drained everything off. So you need to do it at the similar moisture level to gain any knowledge. I mean, if it's dry, it's going to feel like it's compacted. So that is one of the considerations. The other thing that is really critical, and I'm going to say this again at the end, whatever you decide to do and whatever assessments you decide to do, whether it's sending it to a lab, whether you start doing this on your own, you need to do it at the same time of the year and keep records. Otherwise, doesn't matter. Make sure you write down whatever works for your farm. Write down what your plan is. Excel spreadsheet, Word, whatever it is that works for you, and do it at the same time. And soil moisture is always going to be a critical component of that. So, and it's hard. Like there's variation. Then the other thing is to do it in areas that you manage similarly. Right, so if you've got vegetables or you've got an orchard, don't mix up those assessments. And you can do it in time. So if this was my vegetable patch and I was like, I think there's compaction, I went and measured it. I grew cover crops or something. I measured it again the following year about the same time, about the same soil moisture. That's one way to do it. Another way to get a sense of what's going on on your property is to go from like a compacted place to your field, or a fence line to what you're managing. So in place you have two measurements, and you can kind of understand the difference between the two.